Hello everyone, welcome to Augment Tech. In this session, we will be learning about classification in machine learning. By the end of this session, you should be able to understand what is classification algorithm, types of classification, learners in classification problems, types of machine learning classification algorithms, use cases of classification algorithms, logistic regression, how does logistic regression works, coefficient and probability, and k nearest neighbor algorithm. I'm excited to get started and I hope the same from you. Let's get started with classification algorithm. As we know, supervised machine learning can be broadly classified into regression and classification algorithms. So in regression algorithms, we have predicted the value or output for continuous values, but to predict the categorical values, we need classification algorithms. Now, what exactly is classification algorithm? So, classification algorithm is a supervised learning technique that is used to identify the category of new observations on the basis of training data. In classification, a program learns from the given data set or observations and then classifies new observation into number of classes or groups, such as yes or no, 0 or 1, spam or not spam, cat or dog. Similar examples could be male or female, days of week, months of year, etc. Classes can be called as targets or labels or categories. Unlike regression, the output variable of a classification is a category and not a value, such as green or blue, fruit or animal, etc. Since the classification algorithm is a supervised learning technique, hence it is taking input labeled input data, which means it contains the input with the corresponding output. So in classification algorithm, a discrete output function is mapped to input variable x. The classification algorithm is a supervised learning technique. Hence, it takes labeled input data, which means it contains input with the corresponding output. One of the best example of machine learning classification algorithm is email spam detector. The main goal of classification algorithm is to identify the category of a given set, and these algorithms are mainly used to predict the output for categorical data. Classification algorithms can be better understood using the below diagram. In the diagram, there are two classes, class A and class B. These classes are features that are similar to each other and dissimilar to other classes. There we go. Here we have class A, class B, representing the respective features. And then now let's have a look at the types of classification. So algorithm which implements the classification on a data set is known as a classifier, and there are two types of classifications. First, we have binary classifier. If the classification problem has only two possible outcomes, then it is called as binary classifier. For example, yes or no, male or female, cat or dog, spam or not spam. Then we have multi-class classifier. If a classification problem has more than two outcomes, then it is called as multi-class classifier. Example, classification of types of crops, classification of types of music, classification of types of fruits, etc. Now let's have a look at the learners in classification problem. So in classification problem, there are two types of learners. We have lazy learners. Lazy learner first stores the training data set and wait until it receives the test data set. In the lazy learner case, classification is done on the basis of most related data stored in the training data set. It takes less time in training but more time for predictions. Example for lazy learners, we have code-based reasoning and KNN algorithm. And then we have eager learners that develop a classification model based on the training data set before receiving a test data set. Opposite to lazy learners, eager learners take more time in learning and very less time in prediction. Example, we have decision trees, naive Bayes, and artificial neural networks. Now let's see what are the types of machine learning classification algorithms. So the classification algorithms can be further divided into mainly two categories: linear models, wherein we have logistic regression and support vector machines, and then we have non-linear models like k nearest neighbors, kernel SVM, naive Bayes, decision tree classification, and random forest classification. Now let's have a look at the use cases of classification algorithms. Classification algorithms can be used in different places, but some are the below popular use cases of classification algorithms. Here we have email spam detection, speech recognition, identifications of cancer tumor cells, drug classification, biometric identification, etc. Now that was a brief introduction about classification algorithms. Now let's get started with what is logistic regression. So, logistic regression aims to solve classification problems. It does this by predicting categorical outcomes, unlike linear regression that predicts a continuous outcome. Here we'll be using basic logistic regression to predict a binomial variable. This means it has only two possible outcomes. And at the simplest cases, there are two outcomes, which is called binomial. An example of which is predicting if a tumor is malignant or benign. Other cases have more than two outcomes to classify. In this case, it is called multinomial. And a common example for multinomial logistic regression would be predicting the class of an iris flower between three different species. Now let's see how does linear regression actually works. Logistic regression actually works. So in Python, we have modules that will do the work for us, starting by importing the numpy module. So here we do first import the numpy, and then we store the independent variable in x and then store the dependent variable in y. And then from sklearn, we'll import the linear model, and then we create a variable called log r that equals linear model dot will be invoking the logistic regression method, and then we will fit the x and y variables. So here from SK module, we will be using the logistic regression method to create a logistic regression object. And then this object has a method called fit that takes the independent and dependent variables as parameters and then fills the regression object with that data that describes the relationship. And then now we have a logistic regression object that is created and ready. Here we will predict whether a tumor is cancerous based on the tumor size. Now let's have a look at the coefficient probability. So in logistic regression, the coefficient is expected change in log odds of having the outcome per unit change in the variable x. Probability is the coefficient in intercept values that can be used to find the probability that each tumor is cancerous. Now let's see what is k-nearest neighbor algorithm. So k-nearest neighbor is one of the simplest machine learning algorithm based on supervised learning technique. It assumes the similarity between new case or data and available cases, put the new case into the category that is most similar to the available categories. And it also stores all the variables data and classifies a new data point based on the similarity. It means that when the new data appears, then it can be easily classified into a category by using KNN algorithm. And it can be used for regression as well as for classification, but mostly it is used for classification problems in order to classify the new data into a well-suited category. KNN is also a non-parametric algorithm, which means it does not take any assumption on underlying data. It's also a lazy learner algorithm because it does not learn from the training set immediately. Instead, it stores the data set, and at the time of classification, it performs the action on the data set, and it takes time for the prediction. Then KNN algorithm at the training phase just stores the data set, and when it gets new data, then it classifies that data into category that is much similar to the new data. Now, why do we need a KNN algorithm? Let's say there are two categories, category A and category B. And we have a new data point x1. So this data point will lie in which of these categories is the question. To solve this kind of problem, we need a KNN algorithm. With the help of KNN, we can easily identify the category or class of a particular data set. For example, let's say here we have two diagrams. First one depicting before KNN. So here we have a new data point, category A and category B. We need to actually classify this new data point either into category A or either into category B. So after KNN, you can see this new data point is assigned to category 1 as the point color also changes to the points of category A. So this is after KNN. So basically, whatever new data point is coming in, we will be classifying it into a well-suited category. Now, how does this actually happens? How does KNN work? So the KNN working can be explained on the basis of the below algorithm. So we will select the number k of the neighbors and then calculate the Euclidean distance of k number of neighbors. And then we take the k nearest neighbors as per the calculated Euclidean distance. And then among these k neighbors, we'll count the number of data points in each category. Assign the new data points to that category for which the number of neighbors is maximum. And then lastly, our model is ready. So now when working with KNN, we require a value of k. So let's have a look at how does this KNN work. Suppose we have a new data point, we need to put in the required category. Firstly, let's say we will choose the value of k to be 5. Then next we will calculate the Euclidean distance between the data points. Alright, so here you see the new data point is this one, and we have to classify it into category A or category B. So this is Euclidean distance between the point A and B, that is calculated by points x2 minus x1 square plus y2 minus y1 square. So now what we have to do is we're actually getting this root of this, and then so there is no particular way how to determine the value of k. You can either give the value of k to be 5 or k to be 2. So we need to try some values to find out best of them. The most preferred value for k is 5. If we take the value of k low as k equals 1 or k equal 2, it can be quite noisy and leads to effects of outliers in the model. So larger the value of k are good, but it may also find some difficulties. Now let's have a look at the advantages and disadvantages of using KNN algorithm. So the advantages are it is the simplest one to implement. It is robust to noisy training data, and it can be more effective if the training data is huge or large. Disadvantages are always need to determine the value of k, which may be complex sometimes because we have to try again and again taking different values of k. The computation cost is high because of calculating the distance between the data points for the training samples, like we have to calculate the Euclidean distance here. Alright, so this was about the advantages and disadvantages of KNN algorithm. Now we'll hop to Jupyter Notebook and check out the examples of classifications. We will make use of logistic regression to find out if a tumor is cancerous or not. And we will also see an example of a KNN algorithm when a data points needs to be classified into a suitable category. Let's hop to Jupyter Notebook. I'll see you there. Now here I'm on my Jupyter Notebook. So under the machine learning using Python folder, I'm going to create a new Python notebook. Let's name this as logistic regression. And then let's have a heading here that says logistic regression. Now let's say first we will import numpy as np. So here I do numpy as np, and then let's say we will have x points or the data set. Let's say x equals np dot array, and then let's have some values. Let's say 3.78, 2.44, 2.09, and then 0.14, 1.72, 1.65, 4.92, and then 4.37, 4.96, and then 4.52, and let's take 3.69, and lastly 5.88. And then we can do the reshape of this. So here I'll do reshape of -1, comma 1. All right, let's quickly create the y points. Y equals np dot array. So the value of y will be categorical, that is 0 and 1. So here for lesser values we will take 0. Okay, it means uh, that size of tumor is not cancerous. So here we will predict if the tumor is cancerous where the size is 3.46 mm. So here I'll take the values to be 0, 0, 0, 0, 0, and then I think 0 again, and then we'll have 1, 1, 1, 1, and 1. Okay, there should be one more 1. I think we should have 6 zeros and 6 1. Let's check. All right. So now what we will do is here we will use a method from sklearn module. So we'll first import that. So here I do from sklearn, we will import the linear model. And then from sklearn module, we will use the logistic regression. So how to do that? So we will be using the logistic regression method to create a logistic regression object. So here I say log r equals linear underscore model dot logistic regression. And then I can do log r dot fit of capital X comma small y. So we are actually trying to fit the x and y values, or we are trying to pass the x and y variables to our fit method. And now we have a logistic regression object that is ready to predict whether a tumor is cancerous or no based on the tumor size. So the next thing what we will do here is we will predict. Here I say we will predict if tumor is cancerous where the size is 3.46 mm. So here I'll create a variable by name predictions or predicted equals. We'll take that log r dot use the method predict here, predict, and then np dot array, then pass in the array value, let's say that is 3.46, and then we can do dot reshape of -1 comma +1. All right, so now we can actually put all this in one single cell. So what I'm gonna do is I'm gonna use this first, put in here, and then we have the line to import linear model, and then the logistic regression object, and then the predicted variable. All right, so let's go and see what output it gives. Let me print the value of predicted. So here I say print predicted, and there we go. You see the output here is 0. So here we have predicted that a tumor with a size of 3.46 mm will not be cancerous. Now let's say what is coefficient. So here I'm going to write a markdown for coefficient. Let's say coefficient. Coefficient in logistic regression, the coefficient is the expected change in log odds of having the outcome per unit change in X. So this does not have the most intuitive understanding. So let's do it to create something that makes more sense. So what I'll do here is, let's first import numpy as np, and then from sklearn, let's import linear model. All right. So here we'll make we will say reshaped for logistic function. So here I'll say x equals, or let me copy the values from above. All right. Let me take these two x and y points here. And then what I can do is I can simply do log r equals, that is I'm creating a logistic regression object here, equals linear underscore model dot logistic regression, and then log r dot fit, pass capital X and small y to it. And then I'll create a variable by name log odds equals, and then the coefficient of this logistic regression object. So here I do log r dot coefficient, and then odds equals, here I say numpy dot exp, and then pass in log odds to it. And then we can simply print our odds. Let's check if this works. Okay, so here I'm supposed to say np and not numpy, and this should also be odds, and there we go. You see the output here is 4.035. So this actually tells us that the size of tumor increases by 1 mm. The odds of it being a cancerous tumor increases by 4x, or 4 times. Now let's understand what is probability. So here I'm going to write a markdown for probability. Okay, so the coefficient and intercept values can be used to find the probability that each tumor is cancerous. So here we will create a function that uses the model's coefficient and intercept values to return a new value. So here the new value represents probability that the given observation is a tumor. So for this, here let's write an example. So here I say import numpy as np, and then from sklearn we'll import the linear model, and then let's get the x and y points from the above example. Let's take these 2 points, and then I can simply say log r. Let's create the logistic regression object here. Let's say log r equals linear model dot logistic regression, and then log r dot fit of x comma y. Now we will write a function here. Let's say def log, so it's a log it to prob that takes the logistic regression object log r and x as the arguments, and then we will be creating a variable log odds that equals log r dot coefficient into x plus log r dot intercept. And then I can create a variable odds equals np dot exponent of, let's say, log underscore odds. And then we will actually get the probability here. Probability equals odds by 1 plus odds. And then we can simply return the probability. And then lastly, out of the function, we will print, or we will call the function log it to prob, and then we will pass in log r comma x. That is the logistic regression object and the array x. So now if I run, there we go. You see, this is how my output looks like. So for each of the values in x, it is giving me the probability of uh, how much is the probability of the tumor being cancerous or no. So as you can see here, this is 60%, 19, 12, 0.09. And if you can see for the last 6 values, for the last value, if you see in my X array, I have 5.88 as the highest value in my X array, right? So for that, there is a 96% of chance that the tumor is cancerous. So for the value 5.88, the probability that a tumor with the size of 5.88 centimeters is cancerous is 96%. Alright, so now that was about the logistic regression. Now we will see an example of KNN algorithm. So here I'm gonna go back to my main folder, create a new notebook, and let's name this as KNN algorithm. So here I say KNN algorithm. Let's change this to heading and then say K nearest neighbors, that is KNN. So K nearest neighbors is a simple supervised machine learning algorithm that can be used for classification problems or regression tasks. Mainly it is used for classification, and it is also frequently used in missing value imputation. And it is based on the idea that the observation closest to given data points are more similar observations in dataset, and we therefore classify unforeseen points based on the values of closest existing points. So by choosing the value of k, the user can select the number of nearby observations to use in the algorithm. Now let's see how to implement this. Let's see how does it work. So let's say k is the number of nearest neighbors to use. So for classification, a majority vote is used to determine which class a new observation should fall into. So let's have a look at the example. So we need to choose the value for k. Larger the value of k, the better the result. Lesser value of k would give you some noisy result or outcome. So here we will first import matplotlib.pyplot as plt, and then we'll create x and y points. Let's say x is 4, 5, 10, 4, 3, 11, 14, 8, 10, and 13. Let's say this is 12, and then y equals, let's say the points are 21, 19, 24, and then 17, 16, 25, 24, 22, 21, 21. And then we'll create classes equals, let's say 0, 0, 1, 0, comma 0, comma 1, and then 1, comma 0, comma 1, comma 1. And then we can do plt dot a scatter. We'll create a scatter plot for this x and y points, and then specify the classes as c. Let's say c equals classes, and then we can check the plot, and there we go. This is how the plot for this x and y points looks like. Now let's fit the KNN algorithm with k value equals 1. So here I say now we fit the KNN algorithm by specifying the k value to be 1. Let's say here k is the, we are first taking the value of k as very low, that is k equals 1. And then we first need to import from sklearn, we will import sklearn.neighbors. Let's import k neighbors classifier. Let's say if this is correct. Alright, this import statement is correct. So now what we'll do, we'll create a variable data equals, we will zip the points x and y. Okay, and then let's typecast this to list by doing list of zip of x comma y, and then we'll create a variable knn equals k neighbors classifier, and then pass n underscore neighbors equals 1, that is the value of k. And then we can do knn dot fit, to which we can pass a data wherein we have zip the value of x and y, and then pass in the classes. So let's see if this works. There we go. You see here we have now k neighbors classifier with k value 1. Now let's use this to classify a new point. So here I'm going to create a new point, new underscore x equals, let's say the value for new underscore x is 8, and the new underscore y is, let's say 21. And then we'll create a variable new point equals new underscore x comma new underscore y, and then let's create a variable prediction equals knn dot predict, and we will predict the new point. And then let's plot a scatter plot. Here I say plt dot scatter, and then to which we can pass x plus the new value of x comma y plus new underscore y comma c equals classes, and then prediction of 0. And then we will also mark this point on the plot using the text. So here I do plt dot text, and then x equals new underscore x minus 1.7 comma y equals new underscore y minus 0.7, and then I can do s equals, let's format the new point. Here we'll say new point comma class equals to, let's have a named placeholder prediction of 0. And then we can do plt dot show, hit enter. Okay, there's an error. Let's figure out what the error is. So it's here. Yep, this should be plus and not a comma. And then let's run and check, and there we go. You see here we got the new point that belongs to class 0, and the point is x is 8 and y is 21. Let's go and check. X is 8, yep, and y is 21. It falls somewhere here. Alright, so this is the new point that belongs to class 0. And if you notice, the point is here, but it belongs to class 0. So what we will do is now we will check the same thing using the value of k to be 5. Alright, so now we do the same thing by changing the value of k to be 5. Let's see what happens. So here I'm simply gonna say knn equals k neighbors classifier, and then let's pass n underscore neighbors equals the value of k to be 5, and then you can do knn dot fit and then pass the data and classes to it, and then I can create a prediction variable. So here I do prediction equals, let's say, knn dot predict, and then we'll pass new point, and then I can do plt dot scatter. So this remains same. Here we can say x plus new underscore x comma y plus new underscore y, and then c equals classes plus prediction of 0, and then we'll say plt dot text and then pass in x underscore new. This should be x equals new underscore x minus 1.7, and then comma y equals new underscore y minus 0.7, and then s equals, let's format where I say f and then new point comma class equals prediction of 0, and then I can do plt dot show and run. Okay, this gives me an error here for kn. Okay, this should be kn dot predict. Let's quickly run and check, and there we go. You see what actually happens here is now a data point has been uh, created, but here it is class 1. So when we plot the data, all the data along with the new class and new point, we can see it has been labeled blue with class 1. So here the text annotation is just to highlight the location of the new point. This is because here we are using the value of k to be 5. That is, when we change the number of neighbors to be 5, the number of points used to classify our new point changes. As a result, it does the classification of the new point. And then when we plot the class of new point along with the older points, we note that the color has been changed based on the associated class label. Alright, so that was all about the KNN algorithm. Here we have seen uh, an example by passing the value of k, that is the lowest, and the value of k to be 5, and we have seen how the new point is classified based on the lowest value of k and by making k equals 5. So that's all for this session. Hope you enjoyed this session. We'll see you in the next.